This topic will help you in case you will work as a field engineers on energy. Okay, so it's about the instrumentation for energy management. So instrumentation here specifically tools to measure the dimension. Yeah. So okay, so it has been there for quite a long time about measurement. So the most basic thing is probably what will be the length. Okay. Okay, you have length measurement. That's quite common. The distance measurement, that's quite common. And it's for us engineer, it's quite important. This is actually how we can communicate. Okay, language is okay. Word is quite hard to interpret, but number is not. That is why people say that math is actually the language of engineering, language of science. Okay, because when you ask someone what's the distance between your house and your campus, you say it's yeah, and then when you say 1 kilometer, everybody knows what is it. What does that mean? Okay, and in this for energy analysis, we have two types of measurements: the mechanical and electronic or electrical measurements. The first thing is measurement of length. We have all of these tools. Ruler, okay, the caliper here, screw gauge, okay, and then this one you have different type of tools because we know that it's really depend on the precision you want. Okay, a ruler will probably be good when you aim for the 1 millimeter precision. Cantilever will be good if you want to go for 0.1 millimeter precision. Micrometer will be the most accurate measurement if you want as precise as 0.001 millimeter. Okay, so the tools, the selection of the tools is depend on the accuracy you want. Okay, and then the measurement you can use also digital measurement here. It's the same tools as the one before, but now instead of using this, how to say, manual reading, you use a digital reading. Here you have digital display. Some people use laser to measure the distance. I really don't know how it works. Okay, and then you can also use additional tools. Yeah, for example, here someone want to measure the cluster of particle. For example, what will be the size of the particle? So very small. Of course, you cannot use a ruler. You cannot use micrometer, but you can use a technique to measure that one. So, for example, here is using the I know what's the tools using laser. Okay. The next is force measurement. Okay, we can measure force using mechanical tools. For example, counterweight, very popular in wet market. We can use spring, okay, to calculate the force, and it's quite common now to measure the weight. There's an electronic force measurement. We can use strain gauge and the load cell. I have no idea of these two, really. Temperature measurement, we use it for thermal imaging, for example, and it's quite popular when, especially now, if you travel in the airport during the pandemic, they have a very big camera to check the passenger temperature. We use also thermometer to provide the map. So this is thermography maps. We use the thermometer to check health, to measure the skin temperature. Okay, and there are many different types of temperature sensor. Okay, we have a mechanical sensor, electrical sensor. We have other sensors. Okay, liquid thermometer is very simple. It's quite popular. So basically, we have a relationship between the volume of liquid and the temperature. Some liquid will expand when the or shrink when the temperature changes. So the expansion and the shrinkage can be used as a measure of the change in the temperature. There is a gas thermometer. a gas thermometer. So the same thing with gas. So the volume can change. Okay, you can adjust. Okay, when the temperature of the gas is changed, okay, the pressure can be changed if the volume is kept constant. Conversely, we can increase the volume by maintaining the pressure constant. That way, we'll be able to trace the change in temperature from the change in pressure or from the change in volume. There's also bimetal thermometer. This is on the principle of metal will expand or shrink under when there is a change in temperature. Then you can see it mechanically how the scale move from going down or going up. This is a mechanical measurement of temperature, and we have plenty of temperature is very famous. Okay, very common in our daily life. We have a traditional thermocouple measurement. We got an infrared thermometer like the one we use to go whenever we enter to the premise during this time. Okay, basically, the electronic tools is measure some electronic change that related to temperature, and then it's very sensitive. So that is why it's quite common. Okay. Then you have a measurement of pressure. We have different type of pressure gauge. Here is manometer, electronic pressure transducer. This is the same. So I don't know exactly how it works, but it's somehow so there's electronic properties that change when actually the pressure change, and it is captured by the sensor. So I think the best thing I can tell you is that. Okay, then we also have a measurement of flow. It is to measure the flow rate of liquid and gases. There are many applications from here. You're measuring the flow rate of hand pump to the measurement of your blood circulation rate. Okay, we use it in this is a metering of water. I don't know if you ever see it. Very common here when we enter the refueling our gas. It is also used to measure the speed of the plane. So when you measure the speed of the plane, we don't literally measure the movement of the plane. Actually, what we measure is the speed of the wind. Okay, then we can assume, like, for example, it is the wind that is moved and the plane is in the stationary. Okay, that's more or less the same. We do a lot of flow measurement when we generate power. That's the thing. Then a flow meter. There are many different types. Don't really worry about this calculation. It's just I treat this topic as an additional. So it's the same thing as the one before. Flow meters, you can have a mechanical and electronic flow meter. So when it's mechanical, it's really depend on the pressure drop. Okay. And electronic is depend on any signal that is triggered by the motion of the fluid. And we have the most basic is phytostatic tubes. I will not go into detail. Okay, but you see here there is a different in pressure at 0.1 and 0.2. So different in pressure then can be measured using the simple manometer here, delta A. This is delta H. Okay, the same principle is used in the Venturi meter. So you have, for example, here the P1 pressure is higher than P2. As you can see here, the P1 push the liquid down at the difference of H here. Okay, the same. This is the Venturi meters, and orifice meter also the same. So you have this is called vena contracta. So you have from big diameter to small diameter. So basically you have a P1 here and you have a P2 here, and P1 is higher than P2. Then from that one we can measure the pressure. Then we got we can measure the pressure, and then we can link the pressure to the flow. Sorry. Then we have a rotameter here based on the drag flow principle. So you have liquid that's flowing. You have a force, the drag force that move the float according to the scale and so on. You have a turbine flow meter. You have movement of a fluid will rotate this turbine, and then you will rotate the scale, and you'll be able to see how fast the scale rotating. Simple. Also, we have a device for electronic device for flow measurement, gear flow meter, ultrasonic flow meter. It's from sonic sound. You see the many sensor there. And you have an electromagnetic flow meter as well. Finally, we have an electrical measurement of related to energy. I don't know if you still remember your second semester in FIT, because I teach this subject this semester. So you have an oscilloscope and electric signal. Okay, here you use for the practical session. You have a measurement of electrical power. It is available in every house in Brunei when we measure what power we use. And lastly, we have digital analog multimeters.